Naming of negative complex. How to name negative complexes. Okay. So already we have discussed the basic rules of naming coordination compounds and how to name specifically positive complex. Okay. So look at this example. So which one is a negative complex? Okay. So here the coordination sphere is written first. So this is a positive complex. Here the first, what is written? Potassium. Okay. The square bracket is a second term. It's written second. So which means it's a second term, it's negative. It's a negative ion. So it's a negative complex. Okay. So the second one is an example for negative complex. So in negative complex, the square bracket, the coordinate part will be written as a second term. Okay. So all the basic rules is the same. You have to name the positive part first. So here it is potassium. Remember, this is a counter ion here. It's outside the coordination sphere. So this K2, this 2 is insignificant. Okay, whether it is K or K2 or K3 or K4, it doesn't matter. Okay, we simply write potassium. Okay, we won't mention that subscript number. Okay, so that is insignificant. So always name the positive part first. So it's going to be potassium. We start with potassium. Potassium is a metal, right? So whenever you're writing metal, the next thing should be charge of the metal. So potassium is always +1. K is always K plus. So because it has no other charge, if you're not writing the charge of potassium also, it's fine. Because it has only +1. By default, it is +1. Okay, but if it is it's iron, you have to mention the charge because there are two type of iron, Fe2 plus and Fe3 plus. So elements having more than one oxidation state, you have to write. So whenever metal, it's better to write the charge, whether like, so potassium, if you're not writing also, it's fine. But basically we have to write. Okay, so potassium 1. Now the coordinate part, right? So ligands plus metal. So always the rule is name the ligand first. So its name is OH, the ligand is OH minus, right? So for OH minus. So it's a negative ligand, hydroxide ion, right? So it's ending with E. So remove E, add O. So hydroxide become hydroxido. How many hydroxide? 4. So tetra hydroxido. Tetrahydroxido. Now what left? Only like the metal left. So the main difference between the nomenclature of positive and negative complex is on the metal. Okay. So for positive complex, we used the name of the metal as such, cobalt, chromium, nickel as such. Okay. But here, when the metal is being part of negative complex, okay, we have to add the suffix ate with the metal name. So zinc plus ate become zincate. So when to add ate? So when the metal is being part of negative complex, you have to add ate with the metal. Okay, so let's see how the name of the metal changes with ate. Okay, so for zinc, just add ate. If zinc is being part of negative complex, we'll name like zincate. Cobalt become cobaltate. Aluminium become aluminate. Platinum become platinate. Chromium become chromate. So there is a change here. Copper become cuprate. Okay, so that to be noted. Copper is cuprate. Manganese is manganate. Iron, it doesn't matter whether it is iron 2 or iron 3. Okay, if it is coming as a part of negative complex, we use ferrate, not ironate. Okay, it's ferrate. It's important, ferrate. Similarly, silver. We know the symbol for silver is Ag. It's Latin name argentum, right? So its name is coming from the, so when it is part of negative complex, we use argentate. Okay, argentate, not silverate. It's argentate. For tin, what is the symbols? Sn, right? So we use tannate. Okay. For gold, what is simple? It's aurum, right? So aurate. For lead, it's Pb, plumbum, become plumbate. Okay. So for most of the metals, we'll be using their Latin names with ATE. Okay. So iron is ferrate, silver is Argentate, tin is tannate, gold is orate, lead is plumberate. So these are the important changes in the name of metals when they are part of negative. Okay, hope it is clear. So how to name this then? Okay, we'll start with the basic rules. Name the positive part first. So potassium. Potassium. Whenever metal, the charge should be specified. Potassium is always 1. So if you're not writing also, it's fine. By default, it is 1. Okay, so potassium 1. Okay, now now the coordinate part. So always ligand first. 4 hydroxide, right? So tetrahydroxido, 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 and what left? Metal, right? Now metal is part of negative, right? So ate, zincate, no gap. Okay, continuous, zincate. Whenever metal, next to me charge. How to find out the charge? That's from the counter ion. Okay, what is the counter ion? It's K plus ion, right? How many K plus? 2K plus. So if you put in water, the complex split like 2K plus. The total charge of the counter ion is K plus, right? 2K plus, so plus 2. So since the molecule is neutral, it should be balanced by minus 2 by the complex. The total charge of the complex is minus 2. Okay, so what are let H is the charge of zinc, minus is the total charge of the complex. That includes metal plus silicon. So H is the charge of zinc, OH is OH minus of 4, OH minus is minus 4, total charge is minus 2. So what is H then? H is plus 2. Otherwise also you can think like 2 minus 4 is minus 2. So zincate 2, that's it. So the major change is, okay, you have to use AT with the metal. Clear? I hope it's clear. Okay, we'll see more examples. How to name this positive part first. So potassium. So remember, whether it is K3 or K2, it doesn't matter, always potassium. Okay, so the number, the subscript number outside the coordinate sphere is irrelevant. Okay, so potassium 1. Now cyanide. So hexacyanido. It's iron, right? So AT. So not ironate, it's ferrate. Now you have to write the charge. How to find the charge? It's K3 outside, right? So it will be plus 3, 3K plus ion. Okay, so balancing minus 3. Cyanide has minus 6. So 3 minus 6 is minus 3, right? So ferrate 3. Otherwise, also if Fe comes, only 2 possibilities. Okay, so either 2 plus or 3 plus. So this is 3 minus 6 is minus 3. So it's ferrate 3. That's it. So what is the next one? So already we discussed, it's potassium. Okay, tetrahydroxido, zincate 2. Okay, already we discussed that. Now name this one. Okay, so doesn't matter what the subscript is, potassium. Okay, hexacyanido, cyanide, right? It's a negative ligand, so remove E with O, hexacyanido. It's manganese, so manganate, ATE, manganate. What is the charge? Whenever metal is written, charge should be the within the parenthesis. Okay, so this is plus 4 outside, right? 4K plus. So balancing minus 4. So cyanide has minus 6. So 2 minus 6 is minus 4. So manganate 2. 2 is a 2 plus is the charge of the metal ion. The metal ion is Mn2 plus. Okay. Here again, positive part is potassium. Potassium. Okay. What is the ligand? Carbonyl, neutral ligand. So 4 carbonyl, right? So tetracarbonyl. Tetracarbonyl. Okay. What is the metal? Cobalt. So cobaltate, AT, cobaltate. Now charge. So outside is only 1K, so K plus. Balancing minus 1. Forget about this. Okay. Minus 1. So there is no charge for like cobalt. So it should be balanced by, so minus 1 will be the charge of complex. So normally metal won't give, according to the given formula, it's 1. Okay, so normally it won't be negative, metals won't be negative. So but based on maybe the formula is wrong. So like whatever is given, you name like write accordingly. So it doesn't matter plus or minus, right? Cobaltate 1. Okay, now 3H2, right? So trihydrate, 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 okay, dihydrate, 2H2O, tetrahydrate. If it is half H2O, hemihydrate. Okay, just add the number of like water of hydration, hydrate using hydrate suffix. Okay, that's it. Okay, now this one, what is the metal? It's cesium, right? Cesium is in first group, it's always cesium plus, so cesium 1. Okay, now 4 chlorine, right? So tetrachlorido, tetrachlorido. Okay, Fe, so ferrate. Now charge, cesium is cesium plus, balancing -1, right? So like 4Cl minus is -4, so 3 minus 4 is -1, so ferrate 3. Okay, so here what's the difference here? Here only the complex ion is given, the counter ion, the positive part is not shown. Okay, so it doesn't matter, like you just write accordingly. So only coordinates pair is given, so start with ligand. So 6 chlorine, right? Chloride, so hexachlorido, negative ligand, hexachlorido. It's negative complex, right? So ferrate. Now how to find out the charge? Look at the complex charge is 3 minus, like 6Cl is -6, so it should be 3 minus 6, so ferrate 3. Okay, that's it. So you can practice with more questions. It's given in the descriptive box. Okay, so you can click the link and get the worksheet. Okay, you can practice with that. Hope it's clear. Okay, now I will be discussing the neutral complex and some special names in the coming videos. So like keep updating. So please subscribe. Okay, thank you so much.